In this video, we'll use AI to help us create this 2D top-down chopping game prototype in Unity. You'll see exactly where the AI can save you time, like adjusting the import settings, and just as importantly, where it fails short and you have to step in yourself, like when preparing the AutoTile. I'm using Claude Code as my agent with the free 𝗏𝘃𝗲𝗀𝗃𝗲 asset pack. I have unpacked the assets in a new Unity 6 2D project. This assumes you've already connected an AI agent to Unity. I cover the setup in a separate short-format video, link is in the description. In VS Code, I have my Unity project directory opened. In the Claude Code agent session, I will type /mcp to confirm the connection with Unity MCP server. Next, to get started, you can type a prompt like analyze this Unity project, or with Claude Code, just type /init command to let the AI agent analyze our project. Claude Code will create claude.md file, saving the details about our project. First, AI can help us apply the correct import settings to all the sprites that we have added. In our AI agent, let's type a prompt like in the 𝗏𝘃𝗲𝗀𝗃𝗲 folder, we have 2D top-down pixel art assets. Please apply the correct import settings and slicing to each sprite. Ask me questions if you are unsure. Next, send the prompt. Thanks to the last part of the prompt, it might ask you some additional questions to confirm what it should do. After a few minutes, you should see all the sprites with the correct import settings. Character frames have the correct slicing applied, but it didn't adjust the pivot point offset for the characters, nor for the tree sprites. If we place these and add a collider, it lands in the center of the sprite, but for a 2D top-down game, we want it near the character's feet. We could raise each child object by hand, but it's cleaner to set each sprite's pivot on the y-axis to around 0.33. It's just a lot of work. So, we hand that to the AI agent using a prompt like I need you to adjust the pivot points of the character sprites from the units folder. Adjust the pivot of each sprite to a custom value of 0.5 and 0.33. You might need to reslice the sprites. When the AI is done, our character sprites have a custom pivot point applied, and it should work for most characters since those are very similar in size. Next, AI can easily generate for us a base tilemap that we can use to test our gameplay logic and improve later. Our tileset contains two types of grass textures for these near water and those on top of the hills. AI could easily make mistakes choosing the correct sprites. Lucky for us, Unity 6 introduced AutoTile in their 2D Tilemap Extras package. They are like rule tiles, so they will automatically select which tile sprite to use. They are just much easier to set up. Just make sure that you have the 2D Tilemap Extras and editor packages in your project. We can create them manually using right-click, Create, 2D, Tiles, AutoTile. In the inspector, we drag one sprite as the default sprite. Next, we drag the tileset sprite, set the mask to 3x3 and specify the connections between the tiles. 3x3 mask allows us to also use the single line, column or row additional tiles. I have prepared grass hill and hill wall AutoTiles. I will use the AI agent and in the current session give it a prompt like use the grass hill and hill wall AutoTiles from the _tiles folder to create a 50x50 map using Tilemaps. Place the hill wall tile as a single row directly below the bottom edge of the island to simulate depth. Then add three separate, smaller, rectangular hill areas on top of the island on a new tilemap layer sorted above the base, each with its own hill wall row along its bottom edge. Let's send it and see how AI manages it. After a few minutes, the AI has created for us a square base map with some hills. It has added separate tile maps and adjusted the sort order for us. If there are any issues, you can always manually adjust the tilemap. The point is that AI does the tilemap setup for us. Now we can reshape the map however we want, or use it as is to test our movement system. I will just change the camera background to the color of the water, and we have our test map ready. To quickly create a player character that can move and perform chopping action, we can create a new AI session since it's a new feature with new context. I will use a prompt like add a player game object to the current scene and a sprite renderer child object. Use the sprites in the red pawn folder inside the units folder to add idle and walk or run animations and add an animator controller. Add a circle collider and a kinematic rigid body to the player object and allow me to move the player object using the move input action. Use input action reference to connect it. Add a cinemachine to the follow camera. This time I would suggest using the plan mode. This way AI might ask you extra questions to clarify how to proceed. Also, it will show you a plan of action that it wants to take, which you can review and adjust based on what you want to add. Soon, we should have a player game object in our game. AI has prepared the idle and run animations and a script to control the logic with the move input action assigned as per my request. AI has also installed the cinemachine package and added a follow camera to the scene. If we press play, the character should correctly play the animations and rotate when moving. AI has also adjusted the sorting layer for us so that our player will correctly show on top of the tilemap. We can also open our renderer 2D asset and see if AI has correctly adjusted the transparency sort mode. It should have a custom axis with y = 1 for a top-down game. If the pivot is set up correctly, the character should show behind and in front of other objects to simulate depth. If something doesn't work, make sure to describe the current state and the desired outcome, and give the AI hints about the technical details that it should take into account when implementing the fix. In my project, there are no colliders added to the tilemaps, so we can walk anywhere we want. This requires a manual fix. Select the tileset sprite and in the inspector uncheck Generate Physics Shape. Next, open the sprite editor. Here, we want to switch to the custom physics shape editor. We select a side tile, click Generate to add a physics shape, and we can adjust it so that the collider is on the edges of our map. Visual editors like this are something AI struggles with. It works in code but not clicking through Unity's editor window. When you're done, click Apply. Select the AutoTiles and check Has Physics Shape in the inspector. This setting makes the AutoTile use the custom physics shapes, and if those are not defined, it sets the collider to none for those sprites. Finally, let's select our tilemap and add a Tilemap Collider 2D component. And in the scene view, if you have gizmos enabled, you should see our collider that is only on the edges of our map. Now, our player object is using a kinematic rigid body for movement, so we need to manually detect collisions. We still want to have a circle trigger collider adjusted to the shape of our character. That is because for a kinematic movement, collider2d.cast is one way to detect collisions. Let's try asking AI agent to add a collision detection system using this prompt. I have added Tilemap Collider2d to our tilemaps. Player game object has a trigger circle collider. Try using collider2d.cast method to add a collision detection system to the player's movement system. Let's use plan mode again. When the AI is done implementing the plan, we should see that our character can now collide with the edges of the map. Finally, let's add the tree chopping logic. In our assets, we have tree and rock sprites. I have already adjusted the pivot point Y offset to 0.1 for the tree sprites. The pawn character has interact axe animation. We can select our session about the map generation and use a prompt like use the tree sprites from the trees folder to create tree prefabs and scatter them around our map. Try placing 30 trees. Add a circle collider to each prefab to make sure that the player collides with the trees. Once the trees are placed, we'll probably nudge a few into better spots and check each prefab's collider size and adjust it. In our AI session, where we have created the player movement system, let's use a prompt like we need to create a tree chopping game mechanic. Pawn character has axe interact animation. Use it and add to frame 4 a chop animation event. Use jump input action to trigger chopping. We already have 3 prefabs scattered around the map, with colliders assigned. Add the logic where the chop animation event triggers a detection logic in the direction where the player is facing, so left or right. When we detect a tree, change its sprite to a corresponding tree stump sprite, log +1 wood, and disable the chop interaction and the collider on this tree. This is a big task, so let's use the plan mode. AI can ask us some extra questions and eventually will create a plan for us. Make sure to review it and adjust if needed. When AI is done, we should be able to press spacebar to trigger the chop animation. If we stand near a tree, we should see that we can cut it down and the debug.log message shows correctly. We can now walk over the tree stump as requested. With a little polish, we've got a working 2D chopping game prototype. The AI agent can write the code and handle the setup, but the feel, the feedback, the visuals, the design is your job. You direct, and the AI is just a tool that helps you speed up the process. If you want to learn more about using AI agents in Unity, check out my 3D platformer tutorial. Thanks for watching!